Let's see if we can graph these without really plotting points. Okay, so I'm going to use the method of graph your parent function and then do the transformation. So this is a root function, so the parent function is the root function. I'll use light blue for my parent functions. So square root of 1 is 1, square root of 4 is 2, square root of 9 is 3, just to get a decent accurate graph. And then what's the transformation? Let's use purple for my answer. It's a stretch of 3, vertical stretch, so I take these all, multiply by 3, 3 times 1. 4 times 3 would be like way out here, so it's a real big stretch. Something like that. Okay, and that is not a very good graph, but that's 3 root x. And now the negative. So now we take all these points, this guy, and we flip it upside down. So 1, negative 4. Oh, I think I got that one. Let's be careful with this one. Let me fix my graph here a little bit. I think I was off by 1. 3 times 1 is 3. I think I had 4 on there. Square root of 4 is 2. 3 times that is 6. Okay. So I was way off. I did 3 times 4, I think. So let's try that again. And then this one we could do by 3 too. The output here is 3 times 3 on the output would be 9. Oh, that's much better. So I got this looking graph. That is 3 root x. And now we flip it upside down. So I'm down here. And let's see. Let's use black for my final answer. Flip it around the x-axis. That's what this does. Takes all my positive values, makes them negative. So I got 1 point here. I got this point for negative 6 right there. Just a reflection. I think that's right. And then here is my answer. So now I got 3 graphs on there, but this is negative 3 times root x. Okay, how about x minus 3 cubed? I got to understand first that the cubic function is my original graph. 1 cubed, 2 cubed, negative 1 cubed is negative 1, negative 2 cubed is negative 8. So, skinny graph. Parent function, a little extra curve in there, that's alright. And then what does this do? It's 3 units to the right. So I'm just going to move everything over 3 units. 1, 2, 3, 1, 2, 3. And that's not bad. Let's see how we do. Alright, it's just this graph shifted over 3 units. That's the only transformation there. Alright, let's do a couple more. So we should think about the order, right? What order do I want to do the transformation? Well, just like the order if you plug in, you'd square it. So that's my parent function, the squaring. Do a little less accurate with this one. 2. Yeah, okay, let's be accurate. Input 1, output 1, input 2, output 4. Negative 2, output 4. That's good enough. That's x squared. Okay, now what would I do next? Would I move it down 2 or would I take half? Well, the order of operations, you'd square a number, then take half of it. So I'll use purple for my second iteration. So I'm going to take half of all these. Half. This was 4, now it's 2. This was 4, now it's 2. So it's the same graph, only we kind of smashed it down, right? It's called a vertical compression. And now for my final graph, I'll move it down to, that's a 2 unit shift down. So that's my purple points, move them down 2. One, 2. About right. 1, 2. These guys will be my intercepts. 1, 2. And that's it. That's my answer. That's 1/2 x squared minus 2. The purple guy, if you want to label him, that's 1/2 x squared. And then this is my final answer, the black graph, 1/2 x squared minus 2. And of course the original is just x squared. Okay, good. One more. So this one, I got all kinds of transformations. I know it's a root function, so let's just do my original function. That's an easy one. Straight line. Straight line. More or less that's a straight line. That's a little off, but that's okay. Now we're going to take, what are we going to do? Well, I need to be real careful with this one. I need to find my transformations. This one's tough. I want to see the x minus 1 or the x plus 1 or whatever it is in parentheses. That's my left-right shift. I know it's backwards here, but let me show you how I'll get there. I'm going to factor out the 2. 1 minus x. Let's be a little more organized. 1 minus x. And then I need to factor a 1 out of that. Okay? Because I need it to look like one of these. That's what I'm going for. And right now it's backwards. So what happens when you factor, let's just come to the side, when you factor a negative 1 out of this expression? Well, then 1 becomes negative, and the negative x becomes positive. And I'll rearrange it just so I can find that transformation I'm looking for. Okay, so that was just this piece. It's really a 2 out there. So negative 1 times 2 is negative 2. And then this negative and the absolute value bars and the plus 1. Okay, so step by step, let's see what this looks like. Now I put it in the way I wanted it, because this goes way back to when I first described this left-right shift, which is way up here. This one. Right, I just wanted it to be in that form because that's how it's defined. X plus c, x minus c. Right, so I needed to find the x minus 1. So what did I have? I had 2 minus 2x. And I said, I'm going to factor out a 2. I'm going to factor out a negative 1. Negative 1 times 2 is negative 2. And then this would become positive, and this would become negative. All right, just because I wanted it to look like that in order to see my translation. All right, this is a tough one. A lot of translations in this one. All right, so let's see. This is how I have it written right now, and I got to graph this thing. So do your order of operations. First, we shift it 1 unit to the right. 1 unit to the right. 1 unit to the right, and now I got this guy. Okay, that is just absolute value, x minus 1. Now I shift it 2 units, I stretch it out by 2 units. But first we got to be careful with this one because of the absolute value bars. I know that this fact, right, one other thing to consider, those are the same thing, right? The absolute value negative 2 is the same as the absolute value 2. So I can save myself a little bit of work on this one by just dropping that negative sign. Okay, so the next shift would be using the 2, so let's use red for that. So it takes this and stretches everything out. 2, 1 becomes 2, 2. This point is here, and I think that's all I need. That red graph is 2 root x minus 1. Alright, now what? Flip it upside down. Oh, that's pretty easy. Let's use a different color. Let's use dark blue. Upside down. That is negative 2 x minus 1. And then finally up 1. And it's getting a little messy here. Let's go with pink as my final answer. So it's this blue graph moved up 1. So I got to take this point and move it up 1. And do the best I can. I'm running out of room here, but it looks something like that. Okay? And that's the plus 1 shift at the end. So that pink graph is negative 2 negative absolute value 2, x minus 1 plus 1. If I describe the shift, say it's 1 unit to the right, stretch it out by 2, vertical stretch, flip it over the y-axis, and then move it up 1.